Okay, so I have to stop the lab at 2:30 as I have a meeting. Okay, so before 2:30, let me wind up this experiment. Okay, put today's date. Please put today's date. Make it fast. Put today's date. Copy down this. Laboratory experiment number 1. Copy down this. This is the third experiment of our syllabus. Laboratory experiment number 1. Astable multivibrator. Astable multivibrator. Take up the question. Design an astable multivibrator circuit. Design an astable multivibrator circuit for 3 cases of duty cycle. For 3 cases of duty cycle. Using NE555 timer IC. Using NE555 timer IC. Full stop. Simulate the same for any one duty cycle. Simulate the same for any one duty cycle. Simulate the same for any one duty cycle. Copy the question. Put today's date, laboratory experiment number 1, astable multivibrator. Copy the question, aim of the experiment. Design an astable multivibrator for 3 cases of duty cycle, 50%, less than 50%, greater than 50% using any 555 timer IC. Simulate the same for any one duty cycle. Okay, let's see what is multivibrator first. Take up the definition. Take up this line, what I have marked there. Take up the line what I have marked there. A multivibrator is a circuit. A multivibrator is a circuit, electronic circuit. Take up a multivibrator is an electronic circuit which oscillates between high state and a low state. Which oscillates between high state and a low state. Multivibrator is a circuit which oscillates between a high state and a low state. High state and a low state. Okay, now I'll tell you to explain this. High state and low state in the sense, high is nothing but logic 1, low is nothing but logic 0. Andre 0, 1, 0, 1 change ಆಗ್ತಾನೆ ಇರುತ್ತೆ state ಅದು, logic state ಇದರ. I'll show you in the screen now. Okay. Look here, you can see this. You can see that. Okay, you can see that it is a waveform. It is neither at 0 nor at 1. Keeps on changing its state from 1 to 0, 0 to 1, 1 to 0, 0 to 1. Top ಅಲ್ಲಿ ಇತ್ತಂದ್ರೆ it is logic high 1 ಇದೆ ಅಂತ. Okay, bottom ಇತ್ತಂದ್ರೆ it is logic 0, 0 ಇದೆ ಅಂತ. Okay, so it is multivibrator ಅಂದ್ರೆ it is a multi ಅಂದ್ರೆ ಏನೋ multiple 2. Vibrator ಅಂದ್ರೆ it is changing its state from 0 to 1. Again it will not stay in 0. Again ಮತ್ತೆ 1 ಆಗುತ್ತೆ, ಮತ್ತೆ 0 ಆಗುತ್ತೆ, ಮತ್ತೆ 1 ಆಗುತ್ತೆ. The keeps on changing. Okay, such type of devices which will neither be at 0 nor will be at 1, keeps on changing from 1 to 0 is called as multivibrator. Okay, ಈ ಒಂದು ವೇವ್ ಫಾರ್ಮ್ ಸುಮ್ಮನೆ ಬರ್ಕೊಳ್ಳಿ, ಈ ತರ ಒಂದು ಸ್ಕ್ವೇರ್ ವೇವ್ ಫಾರ್ಮ್. ರೈಟ್ ಆನ್ ದಿಸ್ ಸ್ಕ್ವೇರ್ ವೇವ್ ಫಾರ್ಮ್ 1 to 0, 1 0 1 0 ಅಂತ ಅರ್ಥ ಆಗುತ್ತೆ ನಿಮಗೆ. ರೈಟ್ ಆನ್ ದಿಸ್ ಸ್ಕ್ವೇರ್ ವೇವ್ ಫಾರ್ಮ್. Okay, yeah. Take up this line next. There are three types of multivibrator. Bistable multivibrator, monostable and astable. There are three types of multivibrator: bistable, monostable, astable. Take up that. Next week you need to upload your record, to probably record and observation to the Google form. I'll drop you a message. Okay. There are three types of multivibrator: astable, bistable, monostable. Yeah, so let me start designing. Yeah, take up this question, design. Take up this question. Design an astable multivibrator. This question exam ಅಲ್ಲಿ ಕೊಡ್ತಾನೆ ಇದೀನಿ. ಹಿಂಗೇ ಬರುತ್ತೆ. Okay, ಒಂದೇ experiment ಬರೀ software. There is no hardware for this. It's only software. So what I do on the board, if you do it the same in the examination, your job is done. Design an astable multivibrator for the given frequency of 1 kilohertz. And duty cycle of 30%, 50%, 60%. ಯಾಕೆ 3 ಕೊಟ್ಟೆ ಅಂದ್ರೆ ಬಿಕಾಸ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಈಕ್ವಲ್ ಟು 50, ಲೆಸ್ ದೆನ್ 50, ಗ್ರೇಟರ್ ದೆನ್ 50 ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಈಕ್ವಲ್ ಟು 50 ಹಂಗೆ ಕೊಟ್ಟಿದ್ದೀನಿ. ಲೆಸ್ ದೆನ್ 50 ಐ ಹ್ಯಾವ್ ಗಿವನ್ 30%, ಗ್ರೇಟರ್ ದೆನ್ 50 ಐ ಹ್ಯಾವ್ ಗಿವನ್ 60%. ಓಕೆ, ಸೊ ದ ಕ್ವಶನ್ ಈಸ್ ನೀವು ಫಾರ್ಮುಲಾನ ಈ 3 ವ್ಯಾಲ್ಯೂಗೂ ಕಂಡುಹಿಡಿಯಬೇಕು. ಬಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡೋದು ಯಾವ್ದಾದ್ರು ಒಂದು ವ್ಯಾಲ್ಯೂ ಮಾಡಿದ್ರೆ ಸಾಕು. ದಟ್ ಈಸ್ ವಾಟ್ ಹಿ ಹ್ಯಾಸ್ ಟೋಲ್ಡ್ ಇನ್ ದ ಎಕ್ಸಾಮ್, ಇನ್ ದ ಕ್ವಶನ್. Okay, design for all the 3 values, but simulate for any one. Simulate and the software alli madodu. Simulation andre it's nothing but doing it, the experiment in the software. Okay, copy the question. Okay. Let's out of these 3 values, let me take for 60%. Let me design for 60%. Adik munche, you write this circuit. You write this. Okay. So what exactly is this? I'll tell you in a couple of minutes. There are two types of ICs in this world, analog IC and digital IC anta. Analog IC is one where it takes analog inputs. Digital IC is one where it takes digital inputs, okay, in the form of ones and zeros. Okay, so example for digital ICs are your basic gates, logic gate, AND gate, NAND gate, XYZ, all other gates are your basic digital gates, digital ICs. Whereas you know about op-amp, operational amplifier, and 555 timer IC. These two are the analog ICs. These two are the analog ICs. ಎರಡೇ ಇರೋದು analog ICs. op-amp IC ಒಂದು, 555 timer IC ಒಂದು. Okay, both ICs are 8 pin. ಇಲ್ಲಿ ನೋಡಿ 8 pin ಗಿಂತ ಜಾಸ್ತಿ ಇಲ್ಲ ಇದರಲ್ಲಿ. Okay, pin number 1, 2, 3, you can see pin number 1, pin number 2, pin number 3, 4, 5, 6, 7, 8. You can see all 8 pins. Okay, so probably majority of the analog ICs are 8 pin ICs. op-amp is also 8 pin IC. 555 timer is also 8 pin IC. Okay, fine. Now, if you look at this circuit here, okay, so you can see R1, R2, C1, C2. You can see R1, R2, C1, C2. R1, R2 is resistor 1, resistor 2. C1, C2 is capacitor 1 and capacitor 2. Capacitor 1 and capacitor 2. Out of which capacitor 2 value is fixed. Capacitor 2 value is fixed 0.01 microfarad anta. Capacitor 2 value is fixed 0.01 microfarad. Okay, so you are given the pin number 3 is the output pin, stable output anta barutte nodi, kaanta ide illi. Pin number 3 is your stable output pin, that is the where you are going to get the square waveform. Output en gotta idರಲ್ಲಿ square waveform ಬರಬೇಕು ನನಗೆ. Output ಅಲ್ಲಿ square waveform duty cycle ಅಂತ ಕರಿತೀವಿ. T1 ಅಂದ್ರೆ T on ಅಂತ, you can see T1 ಅಂತ ಕಾಣುತ್ತೆ ನೋಡಿ. T1 ಅಂದ್ರೆ T on, T2 ಅಂದ್ರೆ T off. T1 ಅಂದ್ರೆ T on, T2 ಅಂದ್ರೆ T off. T1 plus T2 equals total time period T. ಅಂದ್ರೆ ಆಫ್ ಪೀರಿಯಡ್ ಆನ್ ಪೀರಿಯಡ್ ಎರಡೂ ಸೇರಿಸಿದ್ರೆ ಟೋಟಲ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಟಿ ಅಂತ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಅರ್ಥ ಟಿ ಆನ್ ಈಕ್ವಲ್ಸ್ ಟಿ ಆನ್ ಪ್ಲಸ್ ಟಿ ಆಫ್. ಒಂದು ಫುಲ್ ಟಿ ಟೈಮ್ ಸೈಕಲ್ ಯಾವ್ದಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಆನ್ ಪೀರಿಯಡ್ ಪ್ಲಸ್ ಒಂದು ಆಫ್ ಪೀರಿಯಡ್, ಕಂಪ್ಲೀಟ್ಲಿ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಟಿ. ದೇರ್ಫೋರ್ ಮೇಕ್ ಎ ನೋಟ್ ಇನ್ ಯರ್ ಬುಕ್, ಟಿ ಈಕ್ವಲ್ಸ್ ಟಿ ಆನ್ ಪ್ಲಸ್ ಟಿ ಆಫ್. ಟಿ ಈಕ್ವಲ್ಸ್ ಟಿ ಆನ್ ಪ್ಲಸ್ ಟಿ ಆಫ್. ನಿಮ್ಮ ಕೆಲಸ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಏನಂತಂದ್ರೆ ವಾಟ್ ಈಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ ಆನ್, ವಾಟ್ ಈಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ ಆಫ್, ಯು ಶುಡ್ ಫೈಂಡ್ ಇಟ್ ಔಟ್. Should find it out the value, you should find out the value of T on as well find out the value of T off. Okay, so in turn if you find out T on, if you find out T off, obviously you will get the T. A T ಕಂಡುಹಿಡಿಯಬೇಕು ಅಷ್ಟೇ, ನೀವು ಏನಿಲ್ಲ ಇದರಲ್ಲಿ. ಔಟ್ಪುಟ್ ಅದು ಸ್ಕ್ವೇರ್ ವೇವ್ ಬರಬೇಕು, ಆ ಸ್ಕ್ವೇರ್ ವೇವ್ ಅಲ್ಲಿ ಆನ್ ಪೀರಿಯಡ್ ಎಷ್ಟು ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು, ಆಫ್ ಪೀರಿಯಡ್ ಎಷ್ಟು ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. ಎರಡು ಆಡ್ ಮಾಡಿದಾಗ ಟಿ ಬರುತ್ತೆ ಅಲ್ಲಿ, ದಟ್ ಈಸ್ ಯುವರ್ ಟೋಟಲ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಟಿ. ಓಕೆ, ಸೊ ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ R1, R2 and C1. ಈ ಕ್ವಶ್ಚನ್, ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಡಿಸೈನ್ ಅಂದ್ರೆ ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಂತ. ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ R1 resistor 1, we have to find out the value of R2 resistor 2, and we have to find out the value of capacitor 1 C1. Okay, so ಇದು ಮೂರು ಕಂಡುಹಿಡಿಯಬೇಕು ನೀವು. ಈ ಮೂರು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ we have the formula here. Okay, take up this. I am doing for 60%. Take up this line. For 60, the given frequency is 1 kilohertz. Question nalli, the given frequency is 1 kilohertz. Let me do for 60% duty cycle. The rest too you can do, try it at your home. Okay, we can do for 60% duty cycle. Okay, see the first line. Okay, the 60% is the given duty cycle for the frequency of 1 kilohertz. 60% is the given duty cycle for the percentage of frequency of 1 kilohertz. For the frequency of 1 kilohertz. Okay, step number 1, mark as 1, 2, 3 ಹಾಕೊಂಡು ಹೋಗ್ಬಿಡಿ, ಈಸಿ ಆಗ್ಬಿಡುತ್ತೆ ನಿಮಗೆ. ಈ 1, 2, 3 ಈಸಿಯಾಗಿ ಹಾಕೊಂಡು ಹೋಗ್ಬಿಡಿ. Okay, step number 1, you have been given with the frequency, convert that frequency to time. Therefore T equals 1 by F. F ಕೊಟ್ಟಿದ್ದಾನೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ, ನೀವು ಅದನ್ನ T ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಹೌ ಡು ಯು ಕನ್ವರ್ಟ್ ಇಟ್? ವಿ ನೋ ದ ಫಾರ್ಮುಲಾ, F equals 1 by T ಅಥವಾ T equals 1 by F ಅಂತ. Okay, inverse of time is frequency, inverse of frequency is time. Okay, so can use this formula, T equals 1 by F use ಮಾಡಿ. Okay, use this T equals 1 by F, which will be giving me the value 1 divided by 1 kilohertz. 1 kilohertz ಎಲ್ಲಿಂದ ಬಂತು ಕ್ವಶ್ಚನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ ಅವನು ಅಷ್ಟೇ. ಓಕೆ, ಕೊಟ್ಟಿರೋದನ್ನ ನೀವು ಇನ್ವರ್ಸ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಷ್ಟೇ. 1 by 1 kilohertz, ಕಿಲೋ ಮೇಲೆ ಹೋದ್ರೆ -3 ಆಗುತ್ತೆ. 1 into 10 power of 3 ಆಗುತ್ತೆ ಕೆಳಗಡೆ ಡಿನಾಮಿನೇಟರ್ ಇದ್ರೆ ಮೇಲೆ ಹೋದ್ರೆ -3 ಆಗುತ್ತೆ. therefore it is 1 millisecond. Therefore it is 1 millisecond. Okay, so for the frequency of 1 kilohertz my time is 1 millisecond. Okay, duty cycle ಬನ್ನಿ. come to the second line. Duty cycle ಇಲ್ಲಿ 30% ಮಾಡಿದೀನಿ, but do it for 60%. Okay, duty cycle D equals 60%, which is equal to 60 by 100. You know how to convert the percentage to normal value. Okay, so 60 by 100, which is equal to 0.6, which is equal to 0.6. Okay, take the second formula, second line. D equals 60%, we are doing for 60%, okay, which is equal to 60 by 100, which is equal to 0.6. ಇದನ್ನಂತೂ ಮತ್ತೆ ನಾನು ಮಾಡಲ್ಲ, ಈಗಲೇ ಹೇಳ್ತಿದ್ದೀನಿ. So you have to come to the lab and you have to start doing yourself once when the class starts. Okay, so duty cycle D equals 60%, is equal to 60 by 100, which is having the value of 0.6. Okay, next equation number 1, equation number 2 beda sadik barkobedi. Equation number 1, equation number 2 no need to write down now. Okay, take up this one, take up this line. We know that total time t equals t on plus t off. ನಿಮ್ಗೆ ಆಗಲೇ ಹೇಳಿದ್ದೆ, t on ಅಂದ್ರೆ ಯಾವಾಗ 1 ಇರುತ್ತೆ ವೇವ್ ಫಾರ್ಮ್, ಆ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಕಾಲ್ಡ್ as t on. t off ಅಂದ್ರೆ ಯಾವಾಗ ವೇವ್ ಫಾರ್ಮ್ 0 ಇರುತ್ತೆ, that value is called as t off. When you add on plus off, that gives your t. When you add on plus off, that gives your t. Total time period t equals t on plus t off. Okay, that is first thing you need to understand. Okay, but ನಮ್ಮ ಕ್ವಶನ್ ಅಲ್ಲಿ ಎಲ್ಲೂ t on t off ಕೊಟ್ಟಿಲ್ಲ. ಓಕೆ, ನಮ್ಮ ಕ್ವಶನ್ ಅಲ್ಲಿ ಎಲ್ಲೂ t on t off ಕೊಟ್ಟಿಲ್ಲ, ಬರೀ ಟೋಟಲ್ ಟೈಮ್ ಪೀರಿಯಡ್ t ಮಾತ್ರ ಸಿಕ್ಕಿದೆ. ಹೆಂಗ್ ಸಿಕ್ತು? f ಇಂದ t ತಗೊಂಡ್ವಿ ನಾವು ಅಷ್ಟೇ. ಬಟ್ ವಿ ಡೋಂಟ್ ನೋ ವಾಟ್ ಈಸ್ t on, ವಿ ಡೋಂಟ್ ನೋ ವಾಟ್ ಈಸ್ t off. ಆಯ್ತಾ? ಸೊ ಯುವರ್ ಫಸ್ಟ್ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಇಸ್ ಟು ಫೈಂಡ್ ಔಟ್ ವಾಟ್ ಈಸ್ t on, ವಾಟ್ ಈಸ್ t off. ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಇಟ್ ಔಟ್. Okay, for that you go with this formula, formula number 4. Formula number 1 is f equals to t equals 1 by f. Formula number 2 equals 60% equals 60 by 100 equals 0.6. Formula number 3 equals t on plus t off. Formula number 4, d equals t on by t. D in the duty cycle. Formula number 4, d equals t on by t. D equals t on by t. Okay, ಇಲ್ಲಿ we know that d value as 0.6. ಮೇಲ್ಗಡೆ ಮಾಡಿದೀವಲ್ಲ, 60% ನ 60 by 100 ಮಾಡಿದಾಗ 0.6 ಬಂತು. we know the value of d, we know the value of t. ಟೋಟಲ್ ಟೈಮ್ t ಗೊತ್ತು ನಮಗೆ, ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಇದೆ, ಬಟ್ ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ. ಒಟ್ಟು ಇಷ್ಟು ಬರಬೇಕು ಅಂತ ಗೊತ್ತು, ಅದ್ರಲ್ಲಿ t on ಎಷ್ಟು t off ಎಷ್ಟು ಅಂತ ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. ಓಕೆ, ಈ t f equals 1 by t ಬಂತು, t equals 1 by f ಮಾಡಿದಾಗ ಸೊ t equals 1 milliseconds ಬಂತು. therefore use the formula d, use this formula. Use this. 0.6 equals t on by 1 millisecond. 0.6 equals t on by 1 millisecond. .6 equals t on by 1 millisecond. When you cross multiply, you will get t on equals 0.6 into 1 millisecond, which is equal to 0.6 millisecond. Which is equal to 0.6 milliseconds. t on equals 0.6 into 1 millisecond, which is equal to 0.6 milliseconds. ಓಕೆ, ಈಗ ನನಗೆ ಟಿ ಗೊತ್ತು, ಟಿ ಆನ್ ಗೊತ್ತಾಯ್ತು ನನಗೆ. ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಟಿ ಮೊದಲೇ ಗೊತ್ತಿತ್ತು, ಈಗ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಐ ಗಾಟ್ ಟು ವ್ಯಾಲ್ಯೂ ನೋ ಆಫ್, I even got the value of t on. Okay, now you use the formula number 3 here. Use the formula number 3 here. T equals t on plus t off. Use the formula number 3 there. T equals t on plus t off. Next formula. Adralli I know what is my t, I know what is my t on. Find out t off. I know what is my t, I know what is my t on. Find out t off. Minus madi. T off equals t minus t on. T off equals t minus t on. Okay, which is equal to 1 millisecond minus 0.6 millisecond, which is equal to 0.4 millisecond. Which is equal to 0.4 millisecond. Okay, okay, yeah. Now we know that, hence we got to know t on equals 0.6, t off equals 0.5. You add madi 1 millisecond barutte nodi. 0.6 pet 0.4 is 1 millisecond. So total time period t 1 millisecond ಗೊತ್ತಿತ್ತು ನಮಗೆ, ಬಟ್ t on t off ಎಷ್ಟು ಅಂತ ಗೊತ್ತಿರಲ್ಲ ಅಲ್ವಾ. ಸೊ ಅದಕ್ಕೆ we got to know the formula, and from the formula we calculated and we got to know that t on equals 0.6 millisecond, t off equals 0.4 millisecond. We got this to know. Okay, ಈಗ come back to this. come back to, because I told you in the problem here I should know the value of R1, I should know the value of R2, I should know the value of C1. I should know the value of R1, I should know the value of R2, I should know the value of C1 also. Okay, now we have to find out what is the value. Okay, for that you have to use this formula. Idin barkoli bookaliga. Write down this. T on equals 0.69 RA R1 into C. T off equals 0.69 R2 into C. T on equals 0.69 R1 into C. T off equals 0.69 R2 into C. T on equals 0.69 R1 into C. T off equals 0.69 R2 into C. Okay, coming back to this. Okay, so first we have to find out R1, then we have to find out R2. First we have to find out R1, then we have to find out R2. Okay, so T on equals 0.69 R1 into C. Idರಲ್ಲಿ there are two unknown terms, R1 and C. Both are unknown terms. I know T on 0.69 is a fixed value, R1 is unknown, C is unknown. So ಎರಡು unknown ಇದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ ಇದರಲ್ಲಿ. Okay, so ನಾನು ಏನು ಮಾಡ್ತೀನಿ, I'll assume my C equals 0.1 microfarad. I'll assume my C equals 0.1 microfarad. Okay, so once when you assume 0.1 microfarad, the formula gets changed like this. T on equals 0.69 R1 into 0.1 microfarad. Into 0.1 microfarad. If you do normal mathematical calculation, R1 will be having a value 8.79 K. Barkoli. Okay, similarly apply for second also T off. Similarly apply for T off. This line more line barkoli. Okay, so once when you do this, again if coming back to this diagram only, I'll come back to this diagram directly. Okay, here we have unknown terms as R1, 8.76K igbanth formula dalli. Okay, we have R2 5.76K and you got it from the formula. C1 I have assumed it as 1 microfarad, 0.1 microfarad I have assumed. C2 is a constant. C2 is a constant. Okay, now I have to start rigging up the experiment. Experiment ಮಾಡ್ಬಿಟ್ಟು ನೋಡಬೇಕು. ಇಲ್ಲಿ you have one more here, look here. Pin number ಹೆಂಗ್ ಕನೆಕ್ಷನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ pin number 4 and 8 ಚಾರ್ಟ್ ಮಾಡಿ give it to power supply VCC. ಸೇಮ್ ಇದು ಹೆಂಗಿದೆಯೋ ಹಂಗೆ ಮಾಡ್ತೀನಿ ನಾನು. Okay, okay, then take two resistors, one of 8.79, one of 5.6K and one capacitor of 0.1, another capacitor of 0.01, another capacitor of 0.01. Okay, one capacitor of 0.1 we need R1 of 8.79K, we need R2 of 5.6K. We need R2 of 5.6K. Okay, so if we get all these things, connection properly is very easy. Okay, so short pin number 4 and 8. Short pin number 4 and 8. Okay, from that point give it to VCC. Ade pin number 4 and 8 short ಮಾಡಿ ಆ point ಇಂದ VCC ಕೊಡಿ. Okay, from the same point give it to R1. From the same point give it to R1. Okay, the other next connect the R1 to R2. Connect R1 to R2. Short R1 and R2. Short R2 with C1. Short R2 with C1. Okay, the other end of C1 give it to ground. The other end of C1 give it to ground. Right? Okay, now you have one more C2 capacitor 0.01 microfarad. Okay, connect it from pin number 5 and give it to ground through. Okay, connect it from pin number 5 and give it to ground. Okay, finally pin number 1 is directly ground, so give it to ground only. Pin number 1 is directly ground, give it to ground only. This one, this pin. Okay, directly give it to ground. Okay, so this is the CRO, this is the cathode ray oscilloscope, which is used to see the waveforms. Okay, fine. So we will get this waveform. This is the output what we expect. Okay, va? So idralli we should find what is the T on. We should find what is the T on. We should find what is the T off. That is all our job. Ee tara waveform barutte. Find out what is your T on. Find out what is your T off. Find out what is your T on. What is your T off. Okay. Yeah. So let me share this. I'll take up this. Okay, I'll take up the 555. Idin bandu ಮಾಡ್ತಿರಂತೆ ಇದನ್ನ. I'll just show. This is the timer. You need 2 resistors. Take up resistor number 1, resistor number 2. You need 2 capacitors. Capacitor number 1, capacitor number 2. Okay, so ref left click 90-degree clockwise, 90-degree clockwise. Everything go with 90-degree clockwise. Okay, and as well you need one power supply. So take one VCC and you need one ground. Take one ground here. Take one ground and you can have the CRO here. Fix it like this. You can have the CRO there. You can fix it like this. Okay, start connecting. Short pin number 4, 8 to VCC. From the same point, give it to R1. Connect R1 to R2. R2 back to your capacitor to your ground. This one from pin number 5, again come to ground. This pin number 1 directly will give it to ground. Okay, now pin number 7 connected as shown in circuit diagram. Pin number 6, pin number 2. Pin number 6 and pin number 2. Okay, change the values. Double click on that. 8.76. ಇಲ್ಲಿ kilo ohm ಅಂತ ಇರುತ್ತೆ, kilo ohm ಇರಲಿ. Okay, ಕೊಡಿ. R2 5.85 kilo ohm. Okay, capacitor 1 0.1 microfarad. Okay, capacitor 2 0.01 microfarad. Okay, adu change ಆಯಿತು. Okay, finally the pin number 3 is your output pin. Okay, you have one more G pin here. G pin give it to ground pin. Okay, and you run. You can see the waveform. If you run, you can see the waveform. Wait, I'll show. You can see this waveform. ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಬಂತು ನೋಡಿ, ಸೇಮ್ ಹೆಂಗಿತ್ತು ಹಂಗೆ ಬಂತು. I am measuring my T on here. I am measuring my T on here. Okay, so T on is 0.9 microsecond, 978 microsecond ಇದೆ 978 microsecond ಅಂದರೆ 0.9 millisecond ಅಂತ. Okay, measurement ನ ಬರೆಸ್ತೀನಿ ಆಮೇಲೆ. Okay, and this is your T off. This is your T off. T off is 0.3. ಬರ್ಕೊಂಬಿಡ್ಬೇಕಾರೆ ಬುಕ್ಕಲ್ಲಿ T on is 0.9 millisecond, T off is 0.3 millisecond. T on equals 0.9 millisecond, T off equals 0.3 milliseconds. Okay. Okay, thank you. I have a meeting. I'll see you in next class. Maintain this in the observation book properly.